Today, this channel reached 2001 subscribers. I am so excited about this milestone because 2001 is a special type of number because it can be divided into three unique prime factors. 3 times 23 times 29. This type of number is called a Sphenic number. For example, the smallest Sphenic number is 30, which is 2 times 3 times 5. The next smallest Sphenic number is 42, which is 2 times 3 times 7. 2001, it turns out, is the 303rd Sphenic number. In this video, we're going to use a code to visualize Sphenic numbers using three axes to represent the three prime factors. A Sphenic number, given by px times py times pz, is going to be found at coordinates px, py, pz. So for example, 30 is going to be located at px equals 5, py equals 3, and pz equals 2. 2001 is going to be located at px equals 29, py equals 23, and pz equals 3. So the first thing our code does is creates these three axes to represent the three prime factors, px, py, and pz. We've got one pointing in the x direction, one pointing in the y direction, one pointing in the z direction. Now I'm not going to worry about the length of these axes yet. We're going to adjust that as we need to based on the Sphenic numbers that we create in the graphic representation. This function is the main part of this code. This is where we create the visual of a Sphenic number. Basically, we take in prime factors px, py, pz. We assign a color to the sphere that we're going to create to visualize the Sphenic number and tell it whether to display a label of that numerical value. So first we have to check to make sure that our inputs are primes. So we're using this function here is_prime. This is a pretty straightforward process. Basically what you do is loop over all the possible factors of the number that you're checking, and if it's divisible by any of those numbers, then it has factors. It is not prime. We return false. And if it never escapes, if it never takes that route out of this loop, if it completes this loop, then we return true that the number is a prime. And of course up here we're checking all of the special cases. We're going to go ahead and eliminate even numbers. We're going to check for 1, we're going to check for negative numbers, and we're going to check for non-integers, just so we don't waste time on things that we know are definitely not primes. So scrolling back up, we next need to check for whether these inputs are different from each other. So we're checking to make sure px doesn't equal py doesn't equal pz, and pz doesn't equal px. If we pass both these tests, that we've got three primes and that they're different from each other, then we have a Sphenic number. We can add this number to our display. So we create a sphere at that location as promised, and we're going to give it a size based on the size of the Sphenic number that we're creating. Now for the first case, I think we can bump this up to 3 times 10 to the minus 3. And then here, if we are using the display label option, then we just create a text box that shows you px times py times pz so that we can see what those values are. So if I scroll down to the bottom here where we use the SN function, we're going to test this using the two smallest Sphenic numbers, 30 and 42. So let's hit Control 2 to run this code. And as always, this code is available in a link in the description below. Here we've got our px, py, and pz axis. This time around we're making pz the largest of the three factors, so that's why the pz axis is the longest. And so we've got our 30 over here, our 42 over here. Notice that they have the same px value and same py value. They only differ by pz. So the only difference between these two is increasing pz by, by one step along the prime numbers. So increasing pz by 2, going from 5 to 7. So now let's try our celebratory number for today, 2001. That one's going to have 3, 23, and 29. So you notice all three factors are different, and it is going to be significantly larger than the other two. There's our 2001. This visual is getting a little bit ridiculous, so I think we can safely decrease the scale factor here back to 3 times 10 to the minus 4. There we go, that's a little bit better. So we get an idea that 30 and 42 are hanging out here close to the origin in Sphenic space. 2001 is up here, still pretty close to the, what is that? That's the YZ plane, because it still has a pretty low X value, but it's got a pretty high Y and a pretty high Z value. So this is pretty cool, but it doesn't really give you an idea of all the Sphenic numbers in between 30 and 30 and 2001, because remember, 2001 is the 303rd Sphenic number in the series. So if I come back over here, what I can do is loop over all the possible factors leading up to that. So let's comment this out. And I'm going to introduce down here a loop. Actually, it's 3 loops. We're going to loop over px, py, and pz, going over all the factors that can lead up to 2001. I'm not worried about hitting non-prime numbers along the way, because remember, my SN function is going to reject any attempt to pass a non-prime number through here, and it will reject any attempt to pass matching numbers to here. So I can just loop over these from 2 to 30, well, 2 to 29 without a problem. And basically, for all the ones that aren't 2001 or special number for the day, then we are not going to display a then we are not going to display a label. But for our 2001, let's display a label. Let's point out in red and with a nice little flag what the what our special 2001 number is for today. And notice we're going we're duplicating our loops here, so we're going to get some where px is bigger, some where pz is bigger. I'll show you what that means in just a second. So here we get our 303 Sphenic numbers. You notice we're getting each number 6 times. So you see 2001 occurring 6 times. That's because, for example, here we're keeping the same x value but swapping out y and z. Over here we're keeping the same z value but swapping out x and y. And so each Sphenic number can appear 6 times coming around here. So you get this cool little scooped out crater looking thing. It reminds me of a phase diagram, from thermodynamics class, where you see where you get like the triple line or the triple point for water and all the sublimation and everything for water or carbon dioxide or something. So I think this is a pretty cool graphic. And again, we've got the relative sizes of the spheres to indicate which Sphenic numbers are larger than the others. But of course, what this graphic doesn't tell you is the order of these Sphenic numbers. We know we're going to get to 2001 last in this display, but what path do you have to take to get there? If you wanted to visit each Sphenic number in order, what kind of jagged path would you have to take to get from 30 way down here to 2001 out here? So to help us visualize that, I've made a second code. This one's called Sphenic Tracker. The difference here is that instead of looping over the factors, we're looping over the numbers that we're interested in. So we're going to loop from 30 to 250. I'm not going to take this all the way to 2001 because the graph gets a little bit messy at that point. And basically what we're going to do is check for whether each of those is a Sphenic number. And this is kind of the reverse of what we did before. Now we're looping over all the possible factors that the test number can have. We're taking the product of those factors. If we get the number, then we know we're on the right track. Then we just have to check for whether those numbers are primes and whether those numbers are different. So if we get the right output number, if we get the number we're looking for, and we get 3 prime factors, and those 3 prime factors are different, then we're going to return a few things. First, we're going to return true to say, yes, this is a Sphenic number. And then we're going to return the 3 factors. Now, I've swapped the x and z here because it's a little bit easier to have the larger value along the x-axis than it is to have it along the z-axis. So the easiest way to do that was just to swap x and z. It's the same visualization, kind of like you saw before. You can swap them, you get the same result. And then, of course, if it's not a Sphenic number, we're going to return false. And up here, we're not even going to bother with it because we're only going to check for if that first argument is true. So if that first argument is true, if it is a Sphenic number, then we're going to do 2 things. We're going to create a sphere at the promised location. So here's our 3 factors as a coordinate. So that just marks where we have been in this journey. And we're going to append that same point to this tracker object. So this is a curve object. A curve inputs a list of points and then puts a line segment in between each of the points. So this is giving us both the points we visited and the path in between them. And so let's hit Control-2 to run this. And so here we're moving along the path of Sphenic numbers. You notice we mostly move along the x-axis, But then occasionally we've got to jump up along the Y, and then a couple times we have to jump out along the Z. So we get this cool jagged pattern here. Let's adjust the window a little bit so we can see it better. There we go. It looks to me like it looks to me like the evil sword from the Soul Calibur video game series. It also looks to me like what I imagine a shard blade looks like from the Stormlight archive. So as always, feel free to take this code, modify it, see what neat kind of patterns you can get out of it. You can even print this up and do a little stained glass painting out of it. That might be cool to make. I want to thank everybody, all 2001 of you that have subscribed to this channel. This is a wonderful opportunity for me. I really enjoy getting to share the learning process with you. And if you're not a subscriber and you enjoyed this, feel free to hit the subscribe button below. I try to update with a new video about twice a week, and we try to have a lot of fun. So thank you so much for watching. I will see you next time. Bye-bye.